Hi there, it's Professor McDonald, and in this video I'm going to explain how to complete this Excel math project. And before I get into showing you how to do that, I just want to explain a little bit about why we start with linear regression in my class. Early on in my career, as starting to teach statistics, I had a few professors who took me under their wing and said, you know, students really enjoy doing linear regression first. It kind of helps them get into the interesting aspects of statistics. And so we teach it first. And so I started doing that and I really like it. And I think it offers a lot of opportunities for us as we get started in this course of statistics. So some of the things that we're going to get out of starting with linear regression and specifically out of doing this project here is one, we are going to learn how to use Excel, which is essential for your success in this course. We're going to learn some basic functions, some basic operative skills, some formatting skills, all stuff that's going to be really helpful to you going forward. And also, we are going to learn how to calculate this R correlation coefficient and the coefficients for a linear regression equation, which the full lesson is taught in another video, so I'm just focusing on how to get these calculated values right now. And I'm going to show you how we have built-in functions in Excel that will get those numbers for us, but we can also learn a lot by just calculating them ourselves to get started. So I'm really excited about this lesson. Remember that you can follow along in this video. You're able to pause or back up if it starts to move a little bit too quick for you. That's the beauty of recorded lessons. And I will do my best to move at a rate that helps keep this video down to a pretty manageable size. All right, so now that we're ready to get started on creating this, I'm showing you a PDF version, which is not a spreadsheet version. It's just basically an image with what the finished product should look like and a few details about how to make sure you're doing this the way you're supposed to so that you get full credit. The data shown here was actually collected from one of my classes where we took our shoe size in a man's American shoe. Females would deduct 2 from their normal shoe size to convert it to a man's shoe size. And then we also did our heights in inches. And so those two columns are the paired data, x comma y pairs, that you can plot on an XY coordinate and see if there's some sort of trend. And specifically, we're looking for a linear trend, and linear means line. And you may recall from an algebra course that you learned an equation y equals mx plus b, and that's part of what we're doing down here is we're getting our m and our b for our equation when we calculate these values down here. So we'll talk more about that as we go. So let's begin by just starting with data entry in Excel. So I have an Excel spreadsheet open here, and I'm going to be entering all the data in from the example on the PDF. Now I'm going to show you how you can arrange your screen to help you work a little more efficiently if you're working with all digital materials. Of course, you can print this out if you prefer, but if you want to just be able to use your computer screen, you can minimize windows and then just move them all the way to one side of the screen until it does that, and then let go. And then it fills up half the screen and gives you the option to choose something else to go in the second side. So now I'm able to have a side-by-side view as I'm constructing my spreadsheet to look like this one. Now to start the data entry, I'm just going to begin by putting in some of the labels. Okay, and then I would enter these values in by hand. Now I'm entering into cells, all right, in a spreadsheet you have cells, you have columns marked by letters, and you have rows marked by numbers. So as I'm entering this data in, I'm first entering 7.5 into the cell A2. It has that reference A2 that you see right there. And I'm just going to click on it and then type 7.5 and press enter. And then I'm ready to go on to the next value of 5.5 and so on. So it doesn't take that long once you get the hang of it, but it does take some time. You have to enter them all in by hand, and then you need to double check each and every value to make sure they were entered correctly. That way your calculations will come out correctly. If your data entry is off, then all your numbers are going to be off too. So one of the reasons I want you guys to do this exercise is to experience what it's like to have to enter everything by hand, and then you'll really understand how nice it is that when we do our homework online, we can copy and paste, which is awesome. But for now, we're entering by hand, and I already did enter in those values over here. So I'm just going to put in the labels as you see them there. I'm not doing any formatting just yet, just typing in the important information. Okay, and then all the values that were entered before, I should double check them and just go one by one. 7.5, let's see, 7.5, 5.5, 10, 10, 9.5, 5.5, 9.04, 11, 6.0, 8.5, 5.5, and just go through every single one of these, and it really only takes a few seconds, and it is invaluable. If you don't do this, it can really be a problem. So I'm going to go ahead and start working on getting my other columns filled in. Now the other columns are labeled XY, which means X times Y. And if I want to do a calculation in Excel, I can always put an equal sign in the cell first, and then I can do mathematical operations. So it's kind of like each cell can essentially become a calculator. So I put in the equal sign, and now I'm going to click 7.5 times 65. So now whatever is in those cells is going to be multiplied in this cell. So notice that if I just did 7.5 times 65, I do get that value. But this version here is static, which means if I change these values, um, if I change any one of these values, say I change this to a 10, notice that this one changed because it was made to always calculate the contents of these two cells as a product, multiplying. But this one was only using the static value 7.5 and 65. So that's not helpful to us. What we want is that it's a relative reference formula. So no matter what is in these cells, it's always going to calculate the product. Then in the next cell, it says x caret 2, which means x to the power of 2 or x squared. So equal sign, then I'm going to click on my x, and power is the caret key, 2. Enter. Do the same thing for the y value in that row, to the power of 2. And now I can copy these down to the others relatively so that they will do all the calculations in one quick step. It's awesome. So how do we do that? Well, I have a few things to talk about with you first. Your cursor functions. Notice that my cursor looks like a white cross right now, so it's in select mode. I can select data by holding down my mouse key and dragging. Okay, and so once I have all that selected, then I can also move that selection by going on the edge of the selected cells, and notice it becomes a crosshair, and that has little directional arrows on it, so that if I hold down my mouse key will allow me to just move things around. If I want to move that back to where it was, I can use the undo function or Control Z as a combination on your keypad. And undo comes in extremely handy when using Excel because invariably you will at some point do something you didn't mean to do, and sometimes it's just easier to click the back button or the undo button. Now let's go ahead and select the data again. So notice that I have my white cross. I'm selecting. And now there's one more modality of your cursor. When you go over this little green square at the bottom right corner of your range, it becomes a black plus sign. And now it's in the mode of copying the formulas relatively. And notice that when I click, hold down and drag, and then let go of my mouse key, it's automatically doing all the calculations and populating them accordingly. Isn't that amazing? And let me undo that and show you that you can also just double click. And if you have values, all side by side like this consistently, it'll know how far to go down with that copy. Great stuff, right? I know, it's awesome. And it can save you a ton of time when you know how to do relative formula calculations. We can do a little formatting lesson really quick. Formatting is quite easy for most students to figure out just by playing around on the Home tab in Excel. Down here in this hotbar, there's a lot of different options here. You can also right-click and format cells, and there's a whole bunch of options in the dialog box to get more detailed, right? But even just using these hotkeys, you can do a lot. So first of all, let me share my screen again so that I can see what it's supposed to look like. So if I'm trying to make it look just like this so that I can get full credit for learning all these formatting skills, then I would select the data or the cells that I want to change to have all this look to them. So notice a few things. Looks like they're bolded. It looks like maybe they're italicized, centered horizontally and vertically. It looks like this whole row is kind of made thicker. So notice how I just selected the row. Let me undo that. So I selected the row and then used my cursor to get in between the rows and pull down and resize it. It looks like also we have the background color and the whole thing. If you want to zoom in and out also, just hold down your control key and roll your mouse wheel. I can select all my data and then use this borders menu. I'm going to drop down and select all borders. Okay, so that's looking pretty close to what we have over here. So now we can start working on the calculate R box. So we're going to calculate R, which is the correlation coefficient, the linear correlation coefficient. Then we're going to do all of these things. So you can see we have n, sum of x, sum of xy, sum, oh, I forgot sum of y. So this one was sum of y, sum of xy, and sum of y of x squared, sum of y squared. And let's say I make a mistake and I want to go back in and change that. There's a couple ways you can do that. Click on it, obviously, click on that cell. Then you can go up here into the editor bar and click in and you can move around with your arrow key. You can select, you can do whatever you need to do in there pretty easily. So that's one way to go in and fix it. You can also select the cell, then double click on the area that you want to fix. So if I wanted to change this, I can do that once I've double clicked on the cell. Okay, now we have the R calculation and R squared. All right, so first of all, N. N is the sample size. So let's begin with the first Excel formula that we're going to use, because Excel has some built-in formulas that are very useful in statistics. And one of them that you can use for other reasons but throughout the course is the count function. So I typed it in and then I put a parenthesis, and you can put two parentheses if you like and then just get in between there. And then, you're always going to see this little pop-up that tells you what you're supposed to put in there. So it wants to know what to count. Well, that means you can select a certain range of cells and it'll count how many are in there. And that looks right because 25 is what it's saying. And I have data up until the 26th row. And the first row is just titles. So yeah, it makes sense. There's 25 pairs of XY data, right? You know what I just thought of that I should get it, I should have done in the beginning is give you more of a visual of what we're trying to do. There is a whole video lesson on linear correlation that gives you some background to help you be ready for this section, but I think it'll help me just to show it here. It'll help you for me to show it here. So let's do um, a scatter plot. So I'm selecting all my X's and Y's, and then I'm going to, so select, and then I'm going to insert chart, the one that looks like a dot plot, or a, points, XY points that's the one we want. And there are more details of how to make this look better, but I'm going to try to keep it as simple as possible. I want to make a trend line here. So if you select your data and then right click it, add trend line, make sure it's to linear, then you're just going to select display equation on chart and display R, and that's it. Close that out. And now this little box right here can be moved so you can read it if it's in a weird spot. And now you can see that the R squared value of this data right here is coming up as 0.5013, which actually is incorrect. So I want to double check to make sure. Let me see if I do this again. Just see if anything went weird there, right? Select the data, right click, add trend line, display equation on chart, and yeah, it's weird. It's not selecting, it's not showing what it's supposed to. No. Oh wait, maybe that is right. Is that right? Let's look back at the PDF that has the finished product in it. Oh, it is. It's just that I had it as a percentage. So that's right. So now we know what R squared is as a decimal, which is 0.5013. If we know what R squared is, then we know R is the square root of that number. So notice I did SQRT. That's another very useful formula for Excel. And then I just clicked on the cell containing the R square. So I'm taking the square root to get back to R. You can also do it the other way around. You can do equals correl, which means correlation, and then take your, it says array 1 and array 2. So I'm going to do my A column and then my B column. And now I have that correlation coefficient. I can get R squared by doing an equal sign, clicking on R, and then raising it to the power of 2. All right, and then you can just, to make it look like it looks over here as a percentage, you can right click the cell, format cells, go to number and percentage. And I know it might feel fast, but remember you can pause and back up. So I am trying to move quickly so we don't have a huge long video. All right, so that's how you would find it using Excel functions. So we know what to expect here, but we are going to construct these values using the formula from the book. So let's look up the formula for the linear correlation coefficient R in the book. So let's go over to, I'm just going to show you in Lumen, in the Lumen course, and this should look similar in your Blackboard course because Lumen is, it's coordinated with your Blackboard course, and it should look similar to this. And when you go to the Welcome to Lumen Ohm Students section and roll down to the textbook link, so you'll end up here, and you can go to the table of contents and view everything right in the live version here. You can also download a PDF if you'd like to have one saved to your device so that you can access it easier. It's another option, especially if you anticipate losing internet access and you still want to be able to read and study. You can have that PDF version right there on your device. I'm going to go to the table of contents first and roll down to, this is actually from chapter 12. It's the linear regression and correlation chapter and section 12.1 about linear equations. And then I'm going to go down until I find the one that says linear correlation coefficient. There it is, linear correlation coefficient R. So this is what I want to use, and I'm going to take a snip of that so I can see it easier in my, did I not get it? I wanted my snipper. Snipping tool. New. Okay. That's not what I wanted. Sorry for the fumbling, guys. I think I'm just trying to do it too quickly. I'm getting distracted by some cool stuff that's happening. All right, so now I have the copy of my formula, and I'm going to be trying to calculate this using, right here, I'll just paste it in. And so this little formula here, little, it's not exactly little, is it? That's what we're going to use to calculate r. And notice that it has some things in it, like the sum of x times y. That's why we are going to make a sum of xy piece. The sum of x is going to be here. The sum of y is going to be here. The sum of x squared is going to be here. So we have all the little chunks that we're going to need to create our entire formula to get the r value. All right, so that's what we're aiming for. So we're going to calculate the n using the count function. Whoops. Then the sum of x is the sum of x, then the sum of y, then the sum of xy, then the sum of x squared, and finally the sum of y squared. Okay, and we're going to use this to create our r. All right, now the best way to do this is to start with numerator over denominator because there's a fraction here, right? So I'm going to make, after I put my equal sign in, two sets of parentheses, one over another. Then I can work within each set of parentheses to build my numerator and my denominator. Also notice that my denominator has a square root, and there is a square root function. And I'm going to close the parentheses for that. So I have a set of parentheses on the outside of my denominator and a set of parentheses that's going to contain my square root. Within that square root, underneath the square root sign, notice that there's two more sets of parentheses. So I'm going to have a set of parentheses times another set of parentheses. So that'll allow me the structure for how to build each into each set of parentheses these pieces. So let's begin with the numerator. We have n times the sum of xy. So I'm in between my numerator parentheses, so I'm going to click on n times the sum of xy. Then I have a minus, so I'm going to subtract the sum of x times the sum of y. All right, now that's my numerator finished. I just did all that. Now I'm going to come down to my denominator and work on the first inner set of parentheses here. So that's n times x, the sum of x squareds. So I'm going to click on the n times the sum of x squareds. Then I have a minus sign, then the sum of x quantity squared. So that to the power of 2. I'm going to do the same thing for all the y's over here in the second set of inner parentheses. Then I have n times the sum of y squared. So n times the sum of y squareds minus the sum of y quantity squared. And press enter. And notice now that it matches exactly what the correlation function in Excel gave me. And that is so satisfying. And then to get r squared equals this to the power of 2, and right click, format cells, number, percentage, however many decimal places you want. And so after that, we can work on some formatting a little bit. One of the new features for formatting skills that we're going to learn right now is how to merge. So notice that the title of my Calculate R box extends over 2 columns. So I'd like to format that. So I right click, format, go to alignment, choose merge. Then I'm going to center it vertically and horizontally. So now it's capping off this entire section. And I'd also like to put some borders as shown here. So I'm going to select that range all borders. I notice there's a darker border on the outside, so I'm going to go to my drop down and check thick outside borders. And I'll also do that for here and for here, as it looks like that's what was done here. So I'm just trying to mimic whatever I see. You can also go to the print view if you're interested in seeing how it looks when you go to print. See, so it looks pretty nice. Okay, I'm going to go back, and what else are we supposed to do in this project? Um, let's see, I want to do the actual linear regression equation, so I'm going to need some new pieces to be able to do the formulas for calculating my R. So let's go back to the textbook. That was the linear correlation coefficient, and we use that to tell if there's strong enough linear strength to even use a linear regression equation to make predictions. Again, there's a full lesson on all of this, which is separate. Right now, we're really just focused on how to use Excel to make these formulas happen. So this is a really mathematical focus right now. But we're trying to come up with this formula right here. This is going to give us that linear correlation, or excuse me, linear regression equation that showed up right here when we did our chart. So notice that we had a slope. Remember y equals mx plus b from college algebra? The slope was your m that's attached to the x, and that gives you your rise over run of the line. And then you also have your y-intercept there. So we're trying to calculate those. And so this is going to be equivalent to b in the y equals mx plus b formula. That's the a part right here. That is your y-intercept. And the b represents your slope, m. So we just have different symbols, but they mean the same thing. And then you have right here how you get those equations. So we're going to go ahead and copy those just so we can have them as a convenient view. I'm not sure where I want to put this. I'm going to actually move this out of the way, and then I'll put these here. Wait, what happened? Something odd. Oh, no, it's fine. Okay, we're good. There we go. And I'm also going to snip all this. This gives me the individual formulas for each part of my line. All right, so where A is the average y minus b times x bar. So notice that calculating the y-intercept involves b. And so we actually need to do b first. And b is found using this formula. So let's start constructing all that. So I'm going to pull open this again. So you notice that I have it set up so that we are creating a new table, and we're going to calculate slope. And it's kind of, the title there is cut off. It should say and y-intercept. All right, so then I have x bar, y bar. And so what that really means, x bar and y bar, is the mean of x and the mean or the average of y. Okay, just so that we understand what these things are. And then we have S sub x and S sub y, and these are standard deviations. Standard deviation of x and the standard deviation of y. And you don't learn about standard deviations at all until I think it's lesson 4 maybe. So to get these values, we're going to use average in Excel, the average function, where we just select that column. And we want the average also of the y values. Okay, And then we also want the sample standard deviation. I'm going to just start typing in STD for standard deviation, and notice that there are a couple of options, stdev.p and .s. We want .s because it's for a sample, and then do that again for y. Okay, so now that we have each of those items, we're ready to calculate first the slope, and then the y-intercept, which in this book they call, in some books they call them b sub 0 and b sub 1, and in this book they're calling this one b, and this y-intercept is called a. So, and I think that's the way they're labeled in your graphing calculator also, a and b. So to get b, our slope, we're going to use this formula right here. B equals, and we have a fraction, and then the summation of a product of differences. So that would look like this. I'm going to do a set of parentheses for my numerator and for my denominator. Then inside my numerator, I'm going to do x, wait a minute, wait a second. This formula, this is just not going to work. I can't do it this way. I have to do it a different way. Let's pause because I got to find a different formula. That one's going to be much more involved, and I just realized that it's a different formula than I wanted. So hold on just a moment and we'll get the one we know was going to work better. Okay, I have better formula here, and I just went back to the textbook to get the version that's simpler once you have your correlation coefficient. So we could use this, but it would take, we'd have to create more um, columns, because this is telling us to take each and every individual x value and subtract the mean from it, and then take each and every y value and subtract that mean from it, and it just would be a lot longer since we've already started doing things this way. We have the linear correlation coefficient, so there's an alternate version for calculating b that was shown right here, down here as an alternative. So we're going to use that, and then after we have b, we can use it to find a. Okay, so for B, we're going to use the correlation coefficient calculated there times SY, so that's the standard deviation of the Y values, divided by the standard deviation of the X values. Okay, next we want to calculate the y-intercept, A, which equals the mean of the Y values minus B times, so we just calculated B, we'll use that, times the mean of the X values. All right, and then let's look again side by side so we can see if this came out the way it's supposed to. Let's see. We have B1, 1.1447, that's your y-intercept. B sub 0, 7.0021. Excellent. Doesn't that feel amazing? All right, and we can do the formatting. It's basically the same formatting that we did for this title of this box is going to be the same thing here. So what we can do is something really cool. You can copy it. You can right click and copy, then come down here, right click, and just click on the formatting. The formatting is all we want to copy. Isn't that neat? Quick. Does make it look exactly like the other one. In fact, I think we could do that to most of this. Let's see, let's copy these two. And I don't know if this is going to work, but let's try it. I think you can do it like this. No, that looks weird. Okay, let's just, we'll take one of these guys, copy, and then apply it to all, which kind of silly because it's all we need is borders, but I'm teaching you different things you can do. Right click, format, copy format is what I did there. Also, I can put thick boxes around these guys. Okay, so we're set with the linear regression equation. So notice that those values are the same ones that we also got from this part of our scatter plot when we did the trend line. That matches up with what we have here and here, matches up with our linear equation. So now we're ready for the use model to predict or forecast. And we'll do the input value box. So this will be a place where you just input a value. You leave that blank. We can put 7.5 in there just so that we have the same thing as in the example. Then output, which is also known as your y hat. And the y hat looks like this, a y with a hat on it. And so what we're going to do to use the model to predict is we're going to take the A, which is our y-intercept, plus the B, which is our slope, times this inputted X value. And so that means like I can predict when I have, well, my shoe size is a 7.5 in ladies, so it would be a 5.5 in a man's shoe, American size. So this is predicting that I should be 63.3 inches high. So that's 5 feet and 3.3 inches. And I'm actually 5'4", so that's not a bad prediction, you know? And so if I wanted to know how well this is doing at predicting me, I could do a residual. But you have to actually have paired data. So for me, I do have my own personal um, height. So I could do a residual here and say, well, what is this, the true value, which is 64 inches on me, I'm truly 64 inches, minus the model prediction, and this is called a residual. So there's a residual here of about 0.7 inches. So it's underestimating my height by about 0.7 inches. That's a residual. Okay, now there is a lot more that we could do to play around with residuals and all of that, but this video is definitely long enough. So I will maybe make a separate video for that, or we may just not go there. But if you're interested, look out for that video. And if you know what, if you're interested, definitely request the video, because I like to make things for students when they have an interest in the topic. So I hope that was helpful. I hope you learned a lot. I'm sure you're going to have to watch this again and do it step by step, and it might take you a while to get it down. But believe me, by the time you have mastered the skills that we were doing in this section, you will really feel good going forward as we go into other sections. So be well, and I will see you in the next lesson. Take care.